Okay, so let's run a little bit of a cross validation. So as usual, we are doing um, bottom up. Because in this lab, I'm always doing bottom up approach where we will first build a little thing and then generalize and generalize bigger and so on. So before getting into cross validation, let's just do one thing. Let's just get the sample part of our data set, train it, and then validate on the remaining. All right, so we will call this part cross-validation, but we will see what happens, right? So how are we going to do it? So let us now create training and test data set the following way, right? So we will have a train data set. Look, it's suggesting us something, right? X sample frag 0.8. Yeah, why not? This is actually, this code suggestion, I like it, except I want to say replace is true. Well, we can fix the random state too, right? So it's suggesting us to fix the random state. What is it doing? I don't like this. Replace true means what? It means we are doing sampling with replacement. So as a matter of fact, why don't we do the fraction 1? So I'll explain. So this would be similar to, remember, this will be a similar setup to random forest actually, where we're sampling from X, and sample is a function from the data frame, from pandas data frame, so it knows how to sample instances. So we're sampling from the X. Frac1 means that we are sampling. So if the length of X is 32, we're sampling 32 instances. However, we are sampling them randomly with a replacement. Replacement is basically bootstrapping. So we are doing bagging, but we are doing this extreme kind of random sampling, which will basically make it similar to random forest setup, except we will get only one sample. We'll do cross-validation with more than that, but here we're just doing one sample. Again, remember I said in the lecture that although we're sampling 32 of them, we're sampling them randomly. So inevitably, there will be instances which are sampled twice, and there will be instances which were not sampled, right? Because you are randomly sampling and replacing, sampling and replacing, bootstrapping, right? So we bootstrapped, we got X test, and we need Y train, right? Y train, sorry, X train index. Yeah, I agree with this code. It's not a bad code, right? So X train. Well, we can make it a little more optimal. We can say IDX is equal to X train IDX. Well, one thing I don't like is X dot train. I want X. All right, so this code, I like this code. It looks fine. Drop IDX. We will say IDX. Right, so in the test data set we are not using any X IDX. Then we will use Y train IDX. And in Y test we can use X test, I think. Yeah. So it's pretty good code suggestion from GenAI, but I just wanted to make it a little clearer, right? So I think this is good. Right, now our route will change. So it's suggesting us something. Let's see what is it suggesting. Seems okay. Classes, by the way, right, will be built on the entire data set. So we will reuse the classes which we built before. We are not getting classes from X-train. That's very important because for if the sample was not very good, we may end up with some classes missing in X-train, and then our classes will be missing that, and we don't want it, right? So that's why I want to keep classes from the original data set and Y original, right? IDX. Well, and here I'm going to use IDX from the training. So now my root is on a training sample. My root is on a training sample, and I'm going to create a branch from this, right? So I'll make a branch from this xtrain ytrain root, but maybe let's play with it. Let's make it a little bit like a depth 1 tree, right? So why not? We'll make a smaller tree, right? So let's make it T1 like previously, but it's a smaller tree now. Okay. And now we can make a prediction, right? Y hat is equal to predict. You see, I really like, I'm starting to like this Gen AI more and more. Yeah, so let's see, because see, it suggested me correct code, it seems to me. Let's run it and see. Something didn't work. Right, Boolean X train Y train. Right, so, okay, it suggested me the code, but it was too eager. So that's why this code completion works to some extent. You need to know what you're doing. I'll explain what. The way we wrote make branches, where it accepts indices and so on, is the following. Why is this 1? No, 1 is fine. Make branches. Right, so X and Y should be full X and Y, the entire empty cars data set. Where do we supply the subsample? In the root, because our root is, you see, based on subsample. But X and Y's are, they're the full data set. When we're training, we need the full data set. So that's why autocomplete was incorrect. So I'm using the full data set here, right? But root will filter out. The root, I built a little subtree in a way, right? On a sub-indexes, like on a training data set. When we're predicting though, I'm applying X-test. I'm not using X and Y. That's how I wrote the predict, right? I'm using X-test. That's a design decision I made. So, you know, I thought it was okay. Look, the row names, oh, we didn't say that it's Y hat, so I don't know if it's Y hat or not, right? And then we will say Y. We will say Y true, right? True labels. Let's run them and see. So you see our predictions were 4, 8, 4, but our actuals were 4, 6, 4. So there are some inconsistencies, and now we can calculate the accuracy. So accuracy for multi-label classification can be done this way. Yeah, actually, I think this is correct. So let's see. Accuracy 0.9, right? So in 90% of the cases, we are correct. So let's see how many mistakes we made. We can just like eyeball, right? So this guy was incorrect, right? 4, 4, 8, 8, 4, 8, 4, 4. Well, everything else was correct. So out of, yeah, it's precisely out of 10 instances for testing, only 1 was incorrect. So the accuracy is 90%. And by the way, remember, we had 32 instances, and we sampled with fraction 1, meaning we sampled 32 in training. We can actually test it, right? So let's see. I'll just show you that if we print X train shape, right? Yeah, that's fine. And Y train shape. Maybe X test shape. These two shapes, this should reveal something interesting. Yeah, sorry, lost this. Right, you see it's 32, 10 and 10, 10. So our full data set is 32. Full data set is 32. And by the way, you see, because I fixed my random state, I can rerun and get the same result. 32 and 10, and I sampled into my training data set 32 from the total 32. Yet, 10 of them didn't get in. That's what we were talking about. Remember in the class I said if we're sampling at fraction 1, approximately 67% or like 60 something percent, I think it was 67%, uh, instances will be in the training sample, which means that about 30% will be out. So we are about that. 10 out of 32 is about 30% or so, right? So we will see something like that. So that was like a basic block of, this was a basic block of cross-validation for us. Now we can build on top of this basic block, right? We're doing bottom up. So let's now create the cross-validation where we will run this thing several times. Right, so we will be running it in several times, and we'll get the cross-validation like average accuracy type of deal, right? So let us do this. We will create the code, and then we basically want to repeat this whole thing in a loop, right? We will do it like this, but so what goes into the loop? So let's see. Creating training sample, yes, that goes into the loop. So we will start with a number of iterations, and let's say we'll start with 10, and then we'll say for iteration in range init, that's fine. We will do the whole thing pretty much. Y hat. Right, so we will create a training set. Indices, all that stuff. We probably don't want to be printing it every time. That's too much information. Classes. Oh, it actually, you see it recalculated classes. That's we don't want. Well, we already have it from outside. We already have classes here. So okay, whatever. So let's recalculate classes, but I'll keep them. Oops, sorry. I'll keep them outside of the loop here. Right, so classes will be here. Do we need a root? Yes, we do. We will, because we keep creating this root from the training sample, right? T1. Yes, we need to build a tree, but let's try another tree here. We'll try 3 of this, right? So that's why we will make a copy of this guy so that we don't mess it up, and copy of this guy, and then we'll make it 2. So we made the tree of the tree of depths 1 and 2, and then we get the y hats. That's fine. We will not be printing it. We don't need to print it. So we get the y hat. That's fine. So maybe we get y hats 1 and y hat 2, right? Because test is the same, class is the same, but here the tree changes, right? T2. So we got y hat 1, y hat 2. Now we can calculate the accuracies actually. But that's fine. We will not be printing it. Now we want to accumulate these accuracies. Like we can either create like a table or something, but I want to accumulate them, right? So that's why maybe I will do the following. So I'll create accuracy 1 is I'll say 0. Accuracy 2 is 0, and then we will be doing this plus 1 plus this. Basically, I am adding all these accuracies, and then in the end I'm going to, yeah, that's exactly what I want to do. You see, I'm calculating the average accuracy across all the runs. I mean, for the performance, of course, we would like to get the other, not just averages, but maybe instead of only the mean, we can get standard deviation, stuff like that later. But here I'll just get the mean. It's good enough for me. I think this should work, right? So let's just run it and see. We are running bootstrapping with 10. So our cross-validation, it's stochastic. Bootstrapping, obviously, but cross-validation is only twice, right? Oh, one thing, look, random state. That's not good, right? So we are getting the same instances in all 10 runs. That's not good. So we don't want to do that. We want to remove this random state. You see, you have to, like, when you copy paste, just have to be careful with these little things. Yeah, so we got average accuracy actually higher for the tree of depth 2, right? So for the tree of depth 1, we're getting 0.75% accuracy. And once we increase the depth of a tree, right? So instead of having only tree of 1 level, we have depth 2. We have accuracy a little bit higher, 86%. And basically that was our cross validation. So imagine now we could pick the best tree depth, and then we can in terms of like cross validation performance, and that would inform us about what to do about the tree depth, right? So we're done with this assignment pretty much for I'm sure there are issues here in the code itself, in terms of the code which I wrote is like very quick. You saw it. I just wrote it on screen. So I'm sure there are bugs, like some edge cases and so on. Like a couple of cases which we didn't discuss, I'll discuss in the conclusion.